in a week or two. So now let's look at what this program's doing. It's iterating from 0 to argc again. Okay. It's now iterating from another variable, j equals 0. What do you think string length of argvi means? String length, strlang, is it's just another function. It's in a special library, and it just gets you the length of a string. So what does string length of argvi generally mean? Give me the length of the ith word that the user typed at the prompt. That's it. Give me the 0th word, the first word, the second word, the third word, and get its length. Now, as an aside, how do you figure out the length of a string? How did whoever implemented string length 40 years ago, how did they do it? You just start at the first start of the string and look for what? \0. And then you return the total number of characters you saw before the \0. So that's actually a pretty simple program, a function. But let's see what we're doing. There's one piece of aesthetic difference here. Notice that you can actually declare multiple variables at once inside of a for loop. You just put a comma there. So I'm declaring not only an int called j and setting it equal to 0. I'm also declaring another int called n and setting it equal to the length of the string. And then I'm iterating from j up to n. So from 0 up to the length, because I'm doing j++. So now notice, we can apply this same logic. So again, the syntax is new, but the idea we're just mimicking. If you can index into an array of words called argv with the square bracket notation, but the thing that's there is a string. And what's a string? It's just an array of characters. You can then use double bracket notation to say, give me the ith word and give me its jth character. And if you do that, this seems to empower us now to iterate over all of the lines and all of the words and all of the characters in a string one at a time, printing them out by way of the familiar printf, but this time %c, because it's a character, followed by \n. So in short, what is an array? It's just a contiguous block of memory inside of which are the same types of thing again and again and again, either a word, a word, a word, a word, or in this case, a character, a character, a character, a character. So who cares? Well, it turns out that back in the day, back in Caesar's day, literally, there was something known as the Caesar cipher. And the Caesar cipher is not unlike the grade school flashback I had the other day, whereby you might pass a note handwritten to a significant other in your 3rd grade class, but you want to encrypt it by actually rotating the characters in the message by one place. A becomes B, B becomes C, and so forth. And we teased earlier on Monday that you could do this now programmatically because a letter is just a number, like 65 is A and 97 is lowercase a. So you could actually convert letters to numbers, do some math, and then convert numbers back to letters. And you could do this now with the computer program. And indeed, according to legend, this is exactly how Caesar himself encrypted messages to his generals in the field, taking hopefully a secret number bigger than 1. He didn't just rotate letters in their alphabet by 1, but rather some bigger number or something similar. And so thus was born what's called the Caesar cipher, a rotational cipher whereby you rotate the letters in some word by some number of places. So in problem set 2 next week, you will see the same idea applied, where you'll have to implement your own forms of encryption, your own Caesar ciphers, and some other ciphers whereby you'll take input and have to produce output whose input might be 1, 2, 3, 4, 5, but the output should be something much harder to actually decode or decrypt. And the little teaser here, have about 1 minute left on the clock, is that all of this actually relates to a little thing you see on the screen here, Little Orphan Annie, which is stolen from a movie called, anyone know? A Christmas Story, where little Ralphie has been listening to the radio for ages, hearing secret messages from them, and he tries to decrypt them, and they finally send him Little Orphan Annie's secret decoder ring, which just allows you to rotate the ring and map A to B and B to C and so forth, but in some general way. And so this was Ralphie's and soon your discovery.
Secret Circle is entitled to all the honors and benefits occurring there too.
Signed, Little Orphan Annie. Countersigned, Pierre Andre, in ink. Honors and benefits already at the age of 9. Come on, let's get on with it. I don't need all that jazz about smugglers and pirates.
Listen tomorrow night for the concluding adventure of the Black Pirate Ship. Now it's time for Annie's secret message for you members of the Secret Circle. Remember, kids, only members of Annie's Secret Circle can decode Annie's secret message. Remember, Annie is depending on you. Set your pins to B2. Here is the message. 12, 11.
I am in my first secret meeting.
5, 14, 11, 18, 16.
Oh, Pierre was in great voice tonight. I could tell that tonight's message was really important.
3, 25. That's a message from Annie herself. Remember, don't tell anyone.
90 seconds later, I'm in the only room in the house where a boy of 9 could sit in privacy and decode. Aha, B. I went to the next. E. The first word is B. S. It was coming easier now. U. 25. That's R.
Rosie, I gotta go. I'll be right there, Ma. Gee whiz.
T. O. Be sure to. Be sure to what? What was little orphan Annie trying to say? Be sure to what?
Annie has got to go. Will you please come out?
All right, Ma. I'll be right out.
I was getting closer now. The tension was terrible. What was it? The fate of the planet may hang in the balance.
No, Annie's got to go.
I'll be right out. For crying out loud.
Gee, almost there. My fingers flew. My mind was a steel trap. Every pore vibrated. It was almost clear. Yes, 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 yes.
Be sure to drink your Ovaltine. Ovaltine? A crummy commercial? Son of a bitch.
And thus you have encryption. We'll see you next week.